So now that we've got the battle sequence working almost 100%, there's a few tweaks left, but we can always do that at the end. Now I want to look at how to enter combat and how to exit combat. So to do that, that means there has to be somewhere that you're entering from and exiting to. Typically that's an overworld. So what we're going to do is we're going to create a new scene. It's going to be bare minimum, but at least it'll show the coding as far as how to go from one to the other and then back. So the beginning of that, the basis of that, come up here to File, and we're going to do a new scene. As you can see, everything disappeared because we're in a new scene. If I want to navigate back, I just have to click down here on the battle scene. And what we're going to do is we're going to bring in the images that we're going to use for this new scene. So we're going to drag in that, and we're going to drag in that. Now, what we're going to do is we take our grass image, put it here to create an object, and yes, it's probably the most terrible looking grass ever drawn. Then what we're going to do is we're going to take that and drag it back down here. Now it's an object, so rather than just an image, it actually has these various attributes. Like it has the transform attributes, has the sprite renderer, and then we're going to delete the object. Now we're going to create a new object. This also needs a GM object, so create empty, and it's okay that it uses the same name. They are in separate scenes, so they can have the same name. In fact, you can have multiple objects with the same name in a scene. Just have to make sure that you're referring to the right object. So what this is going to do is this is going to have a script on it. So when you're designing your world, you can manually drag and drop each image to each location, and it's a very tedious process. But if you know what the layout should be, you can have it be calculated. So rather than having all these objects lined up here, because if I want, say I want grass here, grass here, grass here, as you can see, it's going to start adding up. So it makes it very difficult to troubleshoot and work in the system, in the scene. So what we're going to do is in this new script, which is attached to GM, this is where we're going to build the scene. So just like in the past, when one object needs to be made aware of another, we're going to create a variable, save that, and there's the new variable we created. So we need to make sure you're using the prefab, and actually I should move it into our prefab folder. And we click on the GM object, and now it is aware of the grass prefab. The reason for that is now in that same script we can use a calculation to populate the world. Now rather than manually typing this in, I'm just going to go ahead and paste it, and then I'll walk you through what's going on. So this is really the only concept that's new. This is what used to be called a for next loop. Now you don't even have to use the word next, so it's just a loop. What this is saying is it's taken an integer, that's what the int stands for, integer, letter I, and here's the range. It starts at -12. This then says if that integer is less than 12, then increase it by 2. This should look familiar because we've done plus equals and minus equals at a few other places. So again, this is saying that as long as this integer, starting at this number, continues to be less than this number, increase it by 2. Now this should look very familiar. These are instantiate commands. This is why we created a prefab. So rather than having to drag and drop every single one of those grass prefabs over and over again, you simply put in a few statements that do it for you. So let's go through a couple examples. So starting at -12, and as you can see, the x-coordinate is replaced by that integer. So at -12, 4, instantiate 1. Instantiate at -12, 2. -12, 0. In other words, you're going from the top of the screen to the bottom of the screen. It's one of the reasons why I lined it up this way, so it kind of makes sense compared to what you're seeing on the screen. This puts it at the y-coordinate of 4, then the y-coordinate of 2, y-coordinate of 0. There's a slightly better way that you could do this. You could take this for loop and put it into another for loop that controls this, but I figured that'd be a lot to look at, whereas you're familiar with the instantiate command, and so you get that we're just doing this to spell it out, that each one of these is simply a different y-coordinate. And so we'll save this. And there you go. Without any kind of dragging or dropping, you now have, again, really terrible looking grass, but you now have a populated screen. In some ways, this is the basis of what's known as procedurally generated environments. Now in this case, can't quite call it procedurally generated because it's fixed. But if you were to put a randomized statement in here, that rather than saying, okay, it's always going to be grass, if you put in a randomized statement and says it's going to be a tree, the randomized statement randomly chooses maybe a rock or a pit or broken fence, then that's really the basis of what you've heard of as procedurally generated, because there's a random element to it rather than being a fixed construct. So let's now save our work. So we opened a new scene, but we did not actually save it, and we'll just call this Overworld. If you're really doing a full-fledged RPG, you might have a scene for each different land, like these are the marshlands, or these are the highlands, or this is the surface of the moon, whatever. But we'll just call it Overworld because we really just need a launch pad into the battle and then back out of battle. And so now you've got two different scenes. So next is we need to add the character. So we already put her into the assets earlier. So we'll drag and drop, put her there. And she doesn't look like the character on screen. Or should I say the character in battle, I'm just kind of using various assets from other projects. Now what we're going to have to do with her is we need to have her walk around, and when she walks around, that's when it checks for combat. So to do that, let's rename her Hero. Add component, new script. Now here we have to be careful. We can't use the same script name. That would be a problem. So we'll call this Hero Walk. Double click on that. And now what we're going to start doing is we're going to put in more key codes. So we did key codes earlier to check for keystrokes to select attacks. Now we're checking for keystrokes to check for direction of walking. So there are the variables, and now we have to check if they are being pressed. So let's go back to the hero object, and we're going to add another component. So hero is selected, add component, and we're going to go to physics 2D, and again use a rigid body like we did from earlier. Gravity scale will be 0. And one other change I'm going to make is the hero should be ordered layer 1. Now we just start checking to see if a key is pressed. Now before we use get key up, here we want to constantly look for a key being down, because we do want that rapid fire of keeping her walking, or else you'd have to keep hitting the button over and over and over again for every step. So here's why we needed the rigid body. Rigid body 2D to be precise. And so if they are walking up, then it should be 0 for X, positive 2 for Y, oops, sorry, forgot, I had to declare it as a vector 3. Save that, and we'll finish up just by copying and pasting what we just did 3 more times. So I've already modified it, so you can see it's walk down for that variable, walk left for that variable, walk right, and then just have to change the corresponding coordinate. If you're moving them up or down, it's the y coordinate that should move. The greater the value, then the faster they will move. And if they're moving horizontally, then it's the x coordinate that needs to move. So you could have them move 2, 3, 4, 5, whatever speed you want. Save that. There we go.